Hi everyone, today in this video I am going to speak about waves and wave motion. What do you mean by wave motion? Define the term. Explain it with the help of a suitable example and give important characteristics of wave motion. For this question I am going to answer in this video. Wave motion is a kind of disturbance which travels through a medium due to repeated vibrations of the particles of the medium about their mean position. The disturbance being handed over from one particle to the next. In a wave, both information and energy propagate in the form of signals from one point to another, but there is no motion of matter as a whole through a medium. If we drop a pebble into a pond of still water, a circular pattern of alternate crests and troughs spreads out from the point where the pebble strikes the water surface. The kinetic energy of the pebble makes the particles oscillate which come in contact with it. The particles in turn transfer energy to the particles of next layer which also begin to oscillate. Energy is further transferred to the particles of next layer which also begin to oscillate and so on. In this way, energy is transferred from one point to another. Further, if we throw a piece of paper or a cork on the water surface, it is found to oscillate up and down about the mean position and does not move forward with the wave. This shows that it is the disturbance of the wave which travels forward and not the particles of the medium. What are the characteristics of the wave motion? Some of the important characteristics are: in a wave motion, the disturbance travels through the medium due to repeated periodic oscillations of the particles of the medium about their mean positions. The energy is transferred from one place to another without any actual transfer of the particles of the medium. Each particle receives disturbance a little later than its preceding particle. That is, there is a regular phase difference between one particle and the next. The velocity with which a wave travels is different from the velocity of the particle with they vibrate about their mean position. The wave velocity remains constant in a given medium, while the particle velocity changes continuously during its vibration about the mean position. It is maximum at the mean position and zero at the extreme position. For the propagation of a mechanical wave, the medium must possess the properties of inertia, elasticity, and minimum friction amongst its particles. Different types of waves we come across are mechanical waves, electromagnetic waves, and matter waves. Mechanical waves, the waves which require a material medium for their propagation, are called mechanical waves. Such waves are also called elastic waves because their propagation depends on the elastic properties of the medium. These waves are governed by Newton's law and can exist in a material medium such as water, air, rock. Examples of mechanical waves are water waves, sound waves, seismic waves, that is, waves produced during earthquake. Coming to electromagnetic waves, the waves which travel in the form of oscillating electric and magnetic fields. Such waves do not require any material medium for their propagation and are also called non-mechanical waves. Light from the sun and distant stars reaches us through interstellar space, which is almost vacuum. All electromagnetic waves travel through vacuum at the same speed c given by c equal to 3 into 10 power 8 meter per second. Examples of electromagnetic waves are visible and UV light, radio waves, microwaves, X-rays. Coming to matter waves, the waves associated with microscopic particles such as electrons, protons, neutrons, atoms, molecules, when they are in motion, are called matter waves or de Broglie waves. These waves become important in the quantum mechanical description of matter. Examples of matter waves are electron microscopes make use of the matter waves associated with fast moving electrons. Thank you.